Fortunately, the review part isn't on there, but okay, so we know it's 2D because of the units. We're still talking about the original question, right? So what do they're asking us for the scale factor, right? So this is going to be our unknown. So let's substitute in what we do know. Do we know the area of the new? Which one is the new in this case? Yeah, 500, because it's saying you make another kite. So the other kite, that's like the new kite you've made. So that's the 500. Hold on. Now I might confuse you with this. What's better to use here, diagram and actual or new? And because I'm going to read the original question to you here. I should have started a new one, right? Because on a diagram, right, using it, she's making a kite using a diagram, right? So this is your diagram. So what should we rather be using? Diagram and actual. Okay, so my apologies. I'm going to go down here, change this to diagram and actual. My bad. I should have known better. I take full responsibility. Us not having enough time yesterday kind of threw me off a bit. So let's recap, okay? I'd rather use this, and it will happen to you. Just make sure you read, and you're like, wait a minute, no, this is not going to work, right? Let's back up. So now let's try this again. The diagram is what? It's up there. It's 20 centimeters squared. And the actual that she's making, the actual kite, she's just making a bigger version, right? So that's 500 centimeters squared. The units line up perfectly. That's what we want. They cancel out. Make sure you get rid of them. And what are you going to do now? What's the problem here? It's k squared, right? So to get k, what are we going to have to do with the other side? Square root, that's right. Just like Pythagorean theorem, right? If you have a squared side there, you need to take the square root. So this is probably where I need to teach you how to use the calculator, perhaps. So yeah, get your calculators out. So it'll be a moment where I need to show you this feature. So you see the second button, right? Let me zoom out. You press second, and then where the x2 is, there's a square root, a blue one, right? Yours might not be blue, yours might be a different color, but whatever, it's there. And then you see that it's calling the square root, correct? Use brackets. We're going to go 20 divided by 500, close the brackets. That's how I would do it. That way you don't have to worry about rounding or anything like that. And you get 0.2, right? And if I asked you to state this as a fraction, how would you do that? Either you know it's 1 over 5, or math, fraction, and then you get it as a, right, 1 over 5. Or 20%. You should be able to state it in any format that I ask you. Is this, so there you have it. Question, does that answer make sense? What happened to the actual to get to the diagram? It was a reduction, right? And it is true, right? It's a reduction of the original. The diagram is a reduction of the original. So this is good. Okay. Okay. Another question. This one will be a 3D example. Okay. A cargo container has been built using a blueprint with a scale of 1 to 15. A. If the blueprint indicates a capacity of 588.25 centimeters cubed, comma, determine the capacity of the actual container. B. How many times larger is the capacity of the actual container? Okay, so a couple of things here. It's talking about a scale, and we can easily turn that into a scale factor. It's talking about a blueprint. So a blueprint, I would think of that as a diagram. Okay. And we have a 3D, right? This is 3D dimension. Determine the capacity of the actual container. So let's get this set up. Because it's 3D, I'm going to be using k cubed is equal to, you can do capacity if you want, capacity of diagram over capacity of actual. I hope that doesn't throw you off that I'm using capacity, but capacity is how much a container can hold. Volume is how much space it occupies. It's essentially the same. Okay. So we can turn this 1 to 15 into a scale factor by just turning that into a fraction, right? So the scale factor is provided. We don't need to find what it is. It's way up here. It happens to be a fraction. It could be a decimal. It could be a percentage. Don't let that throw you off. So I'm just going to use 1 over 15 as is. Make sure you cube the whole thing, because it won't always be 1. I can guarantee you that. The capacity of the diagram is given to me, which is 588.25. And that's in centimeters cubed. And so the capacity of actual, we can just call that X if we want. So here's where I want you to be careful. I want you to cube each one of them individually. So 1 cubed is just 1. 15 cubed, we can figure out what that is. How would you cube with your calculator? I think if you go to math, there's that cube there. You see that? Math cubed. That's one way. But if that's too much work for you, let's try that. I'm just going to hit enter and then enter again. You can also do 15, and there's that little hat button. In grade 12, you might want to use this. If you press that little hat button, let me show you where it is. It's right underneath clear. It's also an exponent button. So as soon as you press it, you should see that it's kind of highlighting a little power. So you can just press 3, right? We're cubing 3,375. So that's what we write down here. And we just write down the rest like that. And this one is actually pretty easy. Just cross multiply, right? That's just X. And this is 3375 times 588.25. And that is 1985343.75. I'm not going to get you to convert that just yet. I would technically say you should convert that to cubic meters, but we're not ready yet. So we'll just leave it there. And then B, we'll just answer it there. Actual container is, just look at after cubing K, you get the 3,375. And because there's a 1 up top, you can just say it's 3,375 times larger. K cubed times. Just put the K cubed there. I'm just going to leave it like that. K cubed. Are we getting the hang of it? Sort of. Some of you need more examples. I'll give you quite a few today. Right. Question 3. I'm going to use a new page for that. I want it all on one page. So if you're running out of runway, use a new piece of paper. Okay. Okay, a traveling circus. I'm going to write a little faster so I can do the attendance. All right. Write that down. You can already think about it as to how you would try to solve it. What you got there. Let's see if I remember Aaron. Let's see. Gabriel, you're right here. Yeah. Go ahead. Arlene, you're there. Angel. Maxi, you're back there. Janelle, that's you. Okay, sorry. Althea, you're back there. Hannah, Rowan, Raven, Lorraine, that's you. Okay. Annalisa's here. John, here. Both Roberts are here. Zyron, Noah, Zoe's here. Francine is here. Griffin is here. Kim is here. Michaela's here. Robert.
Is that being done here? Is that
390. 390.07. Richard is up front. Camille, I saw you there. I saw you already. Leslie's up front. Zach is here. Ben is here. Trinity left to the bathroom. Eliza, you're back there, right? And Kayla, you're here. Okay. Oh, the attendance is on the video. Anyways, I don't edit. So, fairly loaded question. So I guess we have to determine the language we want to use. Should we use new and original? There's no talk of diagram or blueprint, right? There's just the original and then a smaller one that has been made. So I will call this the large tent is going to be the original. Right? The large tent is going to be original, and this smaller version, small tent, is going to be the new one. Okay. So that's what I'm going to use, new and original here. And so they give us the volume of the original and the volume of the small one. That's hint, hint, right? If they give you both volumes, you can find the scale factor from it, right? So calculate the scale factor used. So for A, I'm going to use K, not just K cubed. And I'm just going to write it down first, volume of the new. I find that if you write it down once, you're less likely to make a mistake. Okay, so K cubed is going to be volume of the new one, which is the small tent. So the 545 cubic meters goes in the numerator. Sorry, I wasn't showing you the whole thing, right? 545 goes there. The 23,366.88 goes in the denominator like that. The units cancel out, which is what you want. Scale factor cannot have units. And then now what? What are we going to take now? The cube root. You remember that from IAPR, taking the cube root? Remember the tree diagrams and all that fun stuff? The prime factors, right? So you go, just copy the whole thing down. I don't like you losing decimals along the way, especially with this calculator, okay? You don't have an excuse really to not use the whole thing. So watch this. Cube root, you got to go math. And there's the fourth option as a cube root there. See it? It's kind of hard to see on the screen there, but. And then just type in using brackets 545 divided by 23,366.88, close brackets, and it's that. Can I get that as a fraction, you think? Math. Oh, before I do that, I'll write down, because this is okay. 286, let's say, right? So that would be fine. That is a scale factor. If you want it as a fraction, I can't do it. See? I tried that, it can't. So you just leave it like that. 0.29 would have been acceptable as well, as long as you round to the correct decimals, right? So that's A. We're done. So because we're relating the volumes, the scale factor has been affected by a factor of 3. That means that if you're trying to find a scale factor by itself, you're going to have to cube root that answer. Okay? For B, it says if the smaller tent has a floor space of 390.07 square meters, I'm going to highlight that, right? Square meters is 2-dimensional. If this is true, determine the floor space of the larger tent. I will say this. We know K, right? It stays the same. Once you find the scale factor that relates to objects that are similar, it doesn't change anymore. You now found the amount that you've changed every dimension by to create that new shape. Okay? So we found it. We can use it now. So we know what K is. I'm just going to go ahead and start saying that K squared is area of the new over area of the original. Do I know my scale factor? Yes, I do. It happens to be a decimal. Doesn't change anything. I prefer you using a fraction, but because we couldn't get it there, we're just going to use the decimal. So 0.286 squared is equal to, where would you place this number, the 390? It's the new, it's the small 10, so it goes up here, okay? Squared meters, so we know our answer is going to be in squared meters as well. So let's go ahead and, how would you do this? Sometimes it's so simple, we make mistakes because it doesn't look like what we've seen before. What I will do here is that it's a little, just a little trick, right? If you put a 1 under any number, you're not really changing its value. But then you still see that it's cross multiplying and dividing. So here's where I want you to be careful. I'm going to leave, you can square it if you want, but I'm going to leave it like that. So times x is equal to 1 times 390.07, which is just that. So you have to divide both sides by this number. You can cancel them out here. So this is what it looks like typing this in. 390.07 divided by brackets 0.286 squared, close brackets, and you get 4,768.82 squared meters. So knowing where to put the numbers is critical. Okay. So let's say you said, no, I don't like having this notation on my paper. I'm going to go ahead and square this right away. Then just make sure you use all decimals, okay? You write them all down, especially because it ends in this case. Write them all down, same thing, right? How are we doing for a Friday? A little bit too much to take, too much to handle? Any questions? Yeah, but any questions other than using the bathroom? No questions? Let's do a chart. I'm going to use my ruler for this. But if you didn't have a ruler, that's fine. Just wing it. I'm not going to mark your... Can I just mention maybe the beauty of how we're doing things here? You don't need to know the exact dimensions of that tent, right? We don't know the height. We don't know, is it round? We don't know. We just know that these are similar, right? One has been made that is smaller. So we know how to find the area of either one just by knowing the scale factor that has been used. Okay, so I don't know, sometimes some students, they forget about it and they try to actually find the volume of the new shape and they tell me, I don't know the height of that cone, right? It's like, you don't need to know the height. You just need the scale factor and one of the volumes, and then you'll be fine. So let's fill in the table below. I will talk about a sphere has a radius of 6 feet, surface area of 452.39 square feet, and a volume of 904.78 cubic feet. Similar spheres have been created as seen below. And this is where the chart is going to start. I'm going to leave 1, 2, kind of just block that off like that. I'm going to call this the original. So maybe wait a little bit until I write down some of the headings and stuff. Scale factor, K, radius in feet, surface area in square feet, volume in cubic feet. This is copy number 1. and this is copy number 2. So now I'm going to start making lines here. I want you to make them tall. Okay, like I'm leaving 2 lines because we're going to do a little bit of work in them, in those cells. There it is. And the original I'm going to fill in already. Oh, yeah. We're okay with the chart. Copy it down. Yeah. So the original will always be identified on a table like this by, it will be providing you with all the pieces that you need to know. Okay. And obviously it has a scale factor of 1, right? Before you do anything, so let's say you're trying to fill in this first row, your number 1 goal is to find the scale factor. Okay. Tables will vary. It may be that the scale factor is somewhere over here. It doesn't matter. But this is your number 1 task, to figure out what the scale factor is. And watch this. Between copy 1 and the original, we know both of the surface areas. You see that? So surface areas affect the scale factor by k squared. Okay, so I'm going to do this here. And it's going to be a little tight perhaps. K squared is going to be equal to, I'm going to go new, right? Area of new, or surface area of new, surface area of the original. So forget about the second copy right now. Just look at those 2 objects. you have your original and the copy is considered a new object, correct? So surface area of the new one is 254.47 divided by 452.39. And we're going to take the square root of that. K is the square root of, oh my goodness, should have left more room, 47 over 452.39. My apologies. But I just want to make sure you have all the work in there. So I'm going to go second x2, and then I'm going to go 254.47 divided by 453.39. Close the brackets, and you get 0.75. 0.75. That's the one you want there. This is what you want. I'm going to highlight that because that's really technically all you want in that cell. Now that you have that, you can do all of the other ones. So radius. Radius is just a one-dimensional, right? This is 1D, this is 2D, this is 3D. So the radius, you can just go like this. K is radius of the new divided by radius of the original. Okay? And what is K? Do I know what it is? Yeah, it's 0.75. Do I need to square it or anything? No, right? I'm trying to be a student. No, you're not going to do it, right? It's because it's one-dimensional that you're relating. You don't need to square, you don't need to cube, you don't need to do any of that. So just, this is going to be our unknown. And do we know the radius of the original? Yes, we do. It's 6, right? So it's really just 6 times 0.75. Which is 4.5. You don't need to do feet or anything because we're told that that is what it is, right? So that's what we highlight. That's what the answer is. Okay. Volume. Volume is K cubed, volume of new over volume of original. And I know I'm going to run out of room there. Can we do a little cheat here? I'm just going to go arrow out like this. Some of you are going to be really upset with me messing up your notes. But this is what you start off with. We know what K is. It's 0.75. We cube it. We don't know the volume of the new, but we're going to find out. We know the volume of the original. And it's basically just this times that. Okay, so volume of new is just 0.75 cubed times 904.78. So we go 0.75 had 3, and you got to be careful. You got to go arrow sideways till it comes back down, or else you're going to continue with the power, times 904.78. So it's 381.70. So that's what we're going to put in here, 381.70 cubic feet. So I put down 381.70 up here. Okay. Can you try the second copy on your own based on what you've just learned? Try to apply what you've just learned for that second copy, right? You forget about copy number 1, forget about it. Now it's original and new, right? It's these two that you're relating. Would you be able to do something like this based on what you've learned so far? Go ahead. And while you do, let's pay attention again. Back up front. So yes, it's volumes. I know both volumes. So it's volume of new over volume of the original. Good job for, like, you need to put it in the right order, and sometimes when it's a chart we tend to mix it up. So it's cube root of that. It is a cube root, yeah. I know this chart is not, it's not the best. I should have given you more room. I apologize for that. The reason I didn't give you as much space is because when I do it, I just have the answers in there. And I found that students needed this step by step, right? How it's done. I won't always do it, but for today I did. So that's 1.25. That's what you should be getting. And then for this, you get it's the original and new. So this is the radius of the new, and this is the original. So it's 6 times 1.25. So that is 7.5. Yeah, 7.5. So that's what you're after there. Last but not least is you take k squared and you say that it's surface area of new, surface area of original. Oh, I'm going to fill it in right away. That's 452.39. So it's really just this times 1.25 squared. And that is, I'm just double checking because my answer key seems a little weird. There we go, 706.86. Is that what we're getting? Okay. I will tell you this, there's a trick to these. Once you find the scale factor, it is basically just multiplying, right? 6 times 1.25, 452.39 times 1.25 squared, and then this number times 1.25 cubed. That's how it goes. You just multiply, okay? So let me, before I hand out the quiz and talk about it, I want you to do page 9 and 10 booklet. So homework, page 9 and 10, booklet. Hold it, plus. This is actually written at the bottom of page 10 in your booklet. It tells you where to go in the textbook. So pay close attention, okay? Monday is a day off for you, right? So in lieu of that, you got to do a little bit of work. There's one typo, as always. That's a classic me every once in a while. This is supposed to be inflated. And 9, it's inflated, not deflated. Okay?